let's see if this will, there we go. So I think the first thing about what we're going to be building ultimately, and again, we're not going to start off on day one working on this. We'll build to getting to start with this, is what are we, like, what type of application are we building here? So the goal of this tutorial is to have you build a Kanban application. And has anyone ever heard of Kanban before, or Scrum or anything like that? A board like this? Well, I'll sort of show you on Trello, but I may even talk through, I think they had a really good screenshot or picture in here. So let me just open that image all by itself, and we'll just focus on this for a minute. So really, it's just a way to plan. That's all it is, a way to plan and do something. It's like a complex to-do list, except it adds a little bit more structure to it. And the idea is, this one's pretty complex here from this picture, but the idea is you might have a few different, these are frequently called things like swim lanes. And all you do is put your items that you want to work on in the first one, like, oh, this is stuff that I want to do. So imagine you're just working on your to-dos for the day. You may have, I want to do the dishes. And so you jot it down on a little sticky note and you put it over in the to-do. And then you're like, I also need to do my homework. And so you write that down and you put it over there. And I need to go walk the dogs. And you put it over there on like your to-do column. And then when you start working on one of those, you'll bring it over and put it into a sort of doing column. This is what I'm working on. So while you're working on the dishes, you'll move it over into there. And then when you're done, you'll move it into the done column. A little heavy-handed when you're talking about just your to-dos at home. You're not going to do that for walking the dogs and stuff. But it's really useful when you're working on a team. Because if one person, if you have a big backlog of work items, and maybe a whole bunch of defects, for example, or a whole bunch of small features to add to your product, and somebody's like, oh man, I have nothing to work on right now, what should I do? They can just sort of go look at this backlog and go, yeah, that looks like a good idea. I've got about enough time to work on that, and move it over into this doing column and communicate to everyone, oh hey, that item's in progress now, so I'm working on it. And then when you talk like each day or talk to the people about what's going on, you already have a column telling people what you're working on. So you can just talk about what's going on in that column and whether stuff is moved over into, we're done with it now, and sort of communicate that information. So that's all a Kanban board is a way to help you keep track of sort of work items like that. And it's pretty common in the software development industry to use this for development. It's not always laid out this way, but it's a pretty common strategy. And other people have found it useful too, which is why there's some pretty large companies like Trello, which I believe got bought up by Atlassian recently. But Trello is probably the most popular Kanban type application out there. And this is their sort of intro. I don't know if they still give people this if you get started now, but this is what they used to have when you started up back in the day with Trello. And you can see you sort of have these things that map to those swim lanes or whatever, these columns. And these ones aren't called doing done because it makes sense to have something a little different. But you can work on these cards and add some information, add other items to it if you want. So here's another card that we added, and maybe move it along between these different boards. If this was actually more complex than I thought. I'm sure there's some way to delete this, but archive, I guess. And that's, I mean, ultimately, something like this is sort of what we're planning to put together through this Survive.js tutorial, where you'll be able to add cards to it, sort of drag them between different items, and do some planning with the software. That's sort of the end goal of that Survive.js tutorial. But before we can get there, we've got a few pieces of technology or background things that we need to go over, especially for the people who just came out of the JavaScript Basics class, because you don't really have the experience or the haven't worked with some of these things before. So what I have planned roughly right now, and we'll see how fast people pick stuff up and how we go through this, is today we did introductions. I'm going to walk through everybody setting up a Cloud9 environment that's the same, just to make sure that we can all get up into Cloud9, have it working, and get this basic workspace working. And then I'm going to go over the concept of Git and source control and how you can work with files and manage sort of a software project that you're working on. So I think the first step today is just getting into Cloud9 and getting an environment set up. So I'll walk through sort of what steps you guys should take while you're setting up your environment. And I'd recommend setting up a new workspace versus the one you were working in before. That way we're all starting with fresh workspaces at the same time in case Cloud9 has changed the configuration of their virtual machines in between, so that we won't have different settings or configurations from each other. So I just created one today. I called it React class. But the process for this, creating it the way that we need to create them for class, is if you're in the Cloud9, you can click on create a new workspace and then give it a name. I just named this one React class, but you can name it whatever you want to name it. I went ahead and left it public for now. And then for the template, I chose the Node.js template. We won't be using too much of the Node.js portion right now, but it's a little more, it gives a little more advanced project than just the HTML one, and it's something that we'll be able to run a quick test on to make sure everyone's got the environment up and running. So then you can create your workspace off of that, and I've already created one over here. Of course, I can't zoom in or out this way, right? I can't even remember how to zoom with this. All right. So once you've gone through those steps, the next step I want you guys to do is open up the README. This may be a little hard to see on the screen up there with the dark color. Let me see if I can change the theme. Why is it only changing that one area? Weird. Yeah. All right, there we go. Probably easier to see right now. But open up the README and follow the steps to run this node server.js. From down here in the console or the command prompt. And then it should tell you that a chat server is listening. And just, if you click on these zeros or whatever, it should allow you to open that up and fire up this just sample app that they have running there. So I'm going to take a few minutes. You know, once you have it working, just put your hand up real fast so I can see as people have gotten through this process. And if you're having a problem, well, I just asked people to put their hands up for that. If you're having a problem, just put your hand up and let me know. And try and get over and help out if we can. You have working or do you have a problem? You have a page instead that says like open the app first in progress. So you can put the button on that. Everybody knows the new environment. And feel comfortable at any time to ask questions. Be like Dan. Dan always asks so many questions. Anybody still getting it set up, or does everyone have it working? Did everybody get the chat example app? Let us know if you did. All download from here. All right. So this is going to be the workspace that we'll live in for most of the class. At least that's the plan. Is working out of this same workspace and working on our project in it. Now, we're not going to be doing a lot of work today in that environment, but starting probably with the next class, we'll build in this workspace and start building up from there. We may have small little projects inside of there for some different stuff, but generally this is what we're going to work out of. So then, let me just make sure I'm not missing anything I wanted to cover. All right, so the next, and really the main topic that I wanted to cover in class today, this might need to get a little bigger still. Should be enough, we'll see, is source control, and specifically Git, because it's sort of become the dominant source control tool. I suspect I'll see most hands go up here, but who has never worked with the source control tool before? At least most of the people from our class. And who has familiarity with Git? Okay. So first, let's try and introduce the topic. What is source control? What is it good for, right? And I'll guarantee you, just about all of you have done something similar to what source control does for you, but you've done it manually. You've done it on your own without knowing that there's a tool to help you do this. So who's ever, I think I've gone through this with my class before, but who's ever written a Word document or some sort of document? You're like, oh no, I need to change it and I need a different version of this. And so you save the first one as .first, .doc, and then you've got another one and you're like .revision, .doc, and then maybe .final version, right? People have done that? Yeah, we've all sort of done that, and that's because you want to keep all these versions around. You want to keep that history in case you need to go back and reference it, in case you need to make a change again. And you don't have an easier way to do that, because if you save over that same document, what happens is you lost your file. You only have the new version of your document. The same problem exists in source control, but even at a higher level, because you're not working with one file when you're working on a project. Like in our Cloud9 workspace here, we don't have one file here. We've got, now we're not, you don't save this folder, but imagine trying to save all the changes to anything in here and the changes to each one of these. This workspace would be cluttered with jQuery.first.js and all these different versions sort of laying around, and you wouldn't be able to keep track of what's going on at all. Especially when you're working with code like this and you're making changes every day to your project. You're just continually changing, continually working with the files. So the solution that software developers came up with for this is what's known as source control. And you can think of it as, let's see if I've got a marker here. It's right. It's like, oh. It's supposed to be. You can think of it like you've got all these versions saved of your file. When you've done that before, and they're different places. Well, here it saves them as well, except you don't have to keep different copies around yourself. You have a separate tool that manages all those copies for you. So what you see, let's talk about the difference between what the Git sees, in a sense, and what you see when you're working with something like this. So we'll just have one file right now, and it can be client.js or something. And we're working with this file. So when we create the first version of this file, and we've just made it, what we'll do when we're working in Git is we'll say, all right, here's my initial version of the file. And we, give it some sort of title or some message that tells us what it is, initial. All right, and then we make some more changes to it, and we've added a feature. I don't know, we can change the colors now or something, right? We don't want to save that because we think we've got it working correctly. So instead of having to create, client.colors.js or a different version of your file, what you'll do is using this other piece of software to manage that interaction. You basically just save your file again and let this other version of the software manage it and tell it, oh, I've got a new version of it where I change colors is now enabled. And it's sort of keeping track of all of these versions of it. But all you're seeing is this one file whenever you're working. So now we make some more changes, and now we've added funny GIFs or something to it, right? And so you've got the funny GIFs change that we made. And notice this whole time what you're seeing doesn't really change. You're still working with one file. And you don't have to keep track of it. But if you want to go back in history and say, oh man, I really want to go back to that change colors version because I screwed something up with my funny GIFs. It's not doing what I want. You can use your tool to go back to these old versions of your file and work with those as opposed to having to remember what version was which and go back to that specific version yourself manually. Does that make sense? Right? Yeah, you're thinking, man, that would be really useful when I'm working on files. I honestly, I don't do it now, but for a while there at least, I was using like a source control tool to manage my whole home folder on some of my computers, so that any changes I made just got checked into source control, and I didn't have to worry about messing something up. So that's the concept, the general concept of any source control tool, and then we're going to go through a sort of introduction to Git and how it does some of that. But the ideas are the same in terms of what it's actually doing. And I'll introduce the other couple concepts that Git has that make this a little more complicated as we work through this. So this Git tutorial, I'm going to encourage everyone to go through it yourself as well. So let me put up the site here so people can see it as well if they're not watching the video, but it's just try.github.io. And we're going to walk through it as a class, or at least a good chunk of it today. But I would really encourage you to go through it yourself after class again. It shouldn't take too long to go through this, just to get some experience of working through these commands and these steps. So the first thing that we're going to want to do, if we're looking at this, says Git allows groups of people to work on the same documents, often code at the same time, and without stepping on each other's toes. Now, we haven't gotten into the multiple people working on it concept of the value this provides yet. We're right now just focused on the idea of managing versions. So the first thing you need to do is you need to tell Git, hey, create this history for wherever I'm at. Like, you need to tell it, you need to manage something for me. I need some history, some structure, so that it can look to me like I'm working with one file, but something is managing all this stuff. And that's what this git init command does. Is it just goes ahead and initializes a new empty repository. So I don't know if these commands will work. We'll see. What it actually does is it creates this .git folder. It's sort of a hidden folder. That's why it starts with a dot. And that holds all this Git information inside of your project, all your version information, so that you don't have to see all of that when you're working with the files. So then, if you want to see what sort of the status of Git is, and this is where it gets a little more complicated than just managing your history. You have to manually manage some of this stuff yourself. You can type git status. And what we see when we type that right here is it tells us we've got our initial commit that we made from that git init, but there's nothing different in our Git environment right now. There's nothing that we need to worry about. And that's sort of what that's saying. So we're going to run it again because that's sort of the next step they have for us. And you wouldn't do this normally without having made some changes yourself. But this is where it gets a little more complicated than just straight managing your versions. Ah, that's really dark. I'll take a change the color of that. So what it's saying here is this is sort of your Git information about what's going on in this folder. Because instead of tracking just one file, it sort of tracks everything you told it to track within a specific location. And it's looking here and saying, oh, I see a file, this octocat.txt, that I'm not tracking. It isn't part of my history. It isn't in my data. And that's what this git status told us. So someone, in this case this tutorial, added a file, and it's not yet in Git. So it doesn't know, it won't know if we made changes to this file. It won't have any history about what's going on. So then if we want to add it to Git, and this is where Git has more than just this timeline going on. Because what Git also sees are files, right? And we want to add this to Git because right now, Git doesn't have any knowledge of any files up here. So there's the, helpfully tells us, so use git add file name to add this file into Git. So we can go ahead and run that. And it says we've added it to the staging area. This is, what is a staging area? What does this mean? This is where, let me see if I can't remember if I found a good thing that I felt like introduced this concept of these three parts. So this is where Git has three sort of places that stuff works in. You've got your working directory. That's what you see.
right? Your working directory, that's what you see at any point in time. And then you have this sort of staging area for Git. And what that staging area is a place to put stuff before it ends up in this, what Git sees history. So the staging area is a way to say, oh, I'm going to put this, add this over to my Git directory. So go ahead and get ready to add that there. You can add it to your Git directory once it's been in your staging area. So if we look at Git status now, oops. What we'll see is we have, instead of what it was saying before, and it might be a little hard to read, so I'll help read it out, is instead of saying that we have an untracked file, it tells us that we have a change that can be committed, which is this new file, octocat.txt. So Git doesn't know about this file yet. We've added it to the staging area, so it's going to know about this file. And now we can save that by using this git commit step. Add cute octocat story. So essentially what that was doing, if we jump back over again to that Git branching model, is we had it in our working directory because we created the file, and then we staged that file, told it, okay, get ready to add this to Git, and then we committed that change into Git, so it actually created the new file. Does that make sense to everyone? Are there any questions about that so far? Yeah? What's that? Where are the semicolons? Oh, like this? Or, let me see which one you're referring to. If you ever, a useful thing on this tutorial, by the way, and I think this works consistently, if you ever run into a problem with it and you need to go back, if you're looking at this sort of timeline on the top, you can just click to the previous section and it should restore it back to that state, and then you can run that command again if you made a mistake. So it's got a sort of fail-safe there for you.
Are you talking about here, or are you talking about parts that you made? This part there. Yeah.
That part, we haven't done this part yet, but
you did do a git add.
We did do a git add for one file so far, yeah. And so what it's telling us now is, and they're sort of doing some work for us to walk us through this tutorial so we don't have to change all these files ourselves. So now it's saying, oh, we added a bunch of other files. So what did we do before when we wanted to check if there was anything new that we had changed since the last time? Anybody remember what we ran? Status. You're gonna get very used to this. Like, git status is probably the most frequently typed command in my console. Git status, git status. I don't know. Oh, what happened? Git status. All the time, because I don't know what the state of my files are. Oh, did I save those? I can't remember. What's wrong? And so even though this is telling us to git add extra files, we can run git status first. And what we'll see is it tells us, oh, here's some untracked files. We've got like this blue octocat.txt, this red octocat.txt, and this octofamily slash, which means Git doesn't know about this folder at all, and it doesn't know about anything inside of that folder. And that's what this command that they have for us up here is git add star.txt. It's saying add all the files that are something.txt into our staging area. So now, once again, if we want to, we can run git status. We can see here's the 4 different files that it added into our staging area that are all new files that hadn't been there before. So just like before, we want to move them from the staging area into our git history. We do a git commit. And this -m command is really just a shorthand so that you don't have to bring up an editor or something else to make this change. And that's the message that you give it. So add all the octocat txt files. So now we've made a few commits into our Git repository, right? And I talked about, if you look over here at this timeline, I said we sort of have like this init, and then we have a color one, and these sort of messages saying what our history is. And yet, if we look at our files right now, we don't see all of this complex history of our files going on, right? All we see are the files that we're working with right there. So it's nice and simple and clean. We don't have to worry about what it was before. But what if we do want to look at our history? What have we changed? That's where the git log command comes in. Because what it will do is log out the result of running each git commit that you've committed. So we can see we've done a couple different commits here. We've added all the octocat txt files. That's our most recent one. And if we go back a little farther, we have add cute octocat story. So that's what I was talking about if we jump over to this timeline where we've got like init or color or those interaction things. You're putting a note there to remind you of what version it was. So when you worked with, you know, Word documents or something, that's like your .first or .final or .revision type history. Does this make sense so far? A little bit. That's why I encourage you to go through this again at home.
So are there any other commands that tell us that are familiar from standard code? Or are they all the same?
I don't know what commands they support in this. I was just trying and hoping that it would work because this is like a little sandbox environment that they created. So most stuff probably doesn't work in this tutorial. That just happens to be one of the few ones that works. Yeah. And those are more from just a Unix environment or Linux environment. They're not node specific in any way. Those are specific to just a command line in a Linux environment. All right, so now we start introducing the more complex capability here, right? So I talked a little bit about, oh, it can handle versioning, and we've done some local versioning. But now we get to do some really cool and powerful things with source control that you're not very familiar with. So who uses Dropbox to store versions of files, right? And Dropbox saves the history of your files up there, doesn't it? Well, Git lets you do something very similar. You can have a remote repository holding a version of your changes. The difference is it won't automatically keep your local stuff in sync. You have to push your stuff up and tell it where you want it to be because this is an open standard. So there's not one site on the internet where you can put content. You can put it wherever you want. And what you do is you tell it, okay, yeah, I'm working locally with Git, but here's a remote site that also is supposed to be the same repository and hold this history. And that's what this command is doing here is it's letting us take this local repository and connect it to a remote place. Yes?
So it doesn't necessarily have to be pushed to
It can be pushed to any Git server. So, for example, in a lot of the groups that we've worked with, we've used Bitbucket, which is a different Git host than GitHub. Other popular ones are GitLab is a really popular Git host. And then a lot of companies just run their own Git server internally because they don't want somebody else to be hosting their source code. So yeah, it's like, I don't even know what to compare it to off the top of my head. I mean, the idea is any sort of server that is running that Git backend, you can connect up to. GitHub is just the most popular one.
one of the big things that just to like kind of classes students when you first encounter this concept is remembering the difference between Git, which is running on your machine, and GitHub or Bitbucket, whatever you're pushing out to do. One of the key things that you just have to keep in mind that
Right. Yeah, it can get very confusing, I think, especially because GitHub is so closely connected in a lot of people's minds with Git that they can't separate the two. So I think that's a very good question. GitHub is different from Git. Git is sort of an underlying technology. GitHub is just a popular Git hosting site. So the step we have next, this one is we're going to add a remote site. And this is a little convoluted. It's not something you're going to remember. Don't worry. You don't have to do this all the time. And pretty much anytime you do it, you're going to have a little cheat sheet that will help you out. I'll show you an example of that in just a second so that you can feel that way. But they've got the exact steps you need to do here. So basically what you're doing with this set of instructions is you're telling it, I want to add a remote site that this content is connected to. This is going to be the origin. And there's nothing requiring you to name it that. That's just the common name for the site that you usually push your content up to is origin. And then this is the URL for where it's going. So we can go ahead and add that. And then the next step after that, so what we've basically done is said, all right, we've got our local Git here, and you can imagine, if you will, all of this is on your computer up till now. And now we've got a cloud up here with some other Git thing, and we're connecting to it and saying, oh, this stuff is connected here in some way. But what we haven't done yet is send any of this into the cloud. We haven't told it, oh, actually upload all that content up there. All we did is say, create a connection between the two. And now we need to tell it, ooh, but send the content up there also so that you have this. And that's what this action is git push -u origin master. And this master and origin bit will make a little more sense as we keep working. But what you're telling it is push this content up to the origin, and what I'm pushing up there is the master branch. And you'll understand branches in just a little while. But now, what we just did was push our content of our master branch, the current commit and all of the history, up into our remote site as well, so that it has that version of the files, the same version that we've been working with locally. Well, you can also do the inverse, like, you know, Dropbox does this automatically for these individual files, but you want to be able to manage this yourself when you're working with source code, because if you're working on a team and I'm working on feature A and Dell is working on feature B, and they need to change some of the same files, or they may, well, I don't want any of Dell's changes on feature B to affect what I'm doing. I want to be able to work on my stuff completely independently, know that I have it working, and then send it up into the cloud. And he wants to be able to work independently. He doesn't want to be working and then suddenly have his system pull down a change of a file that he was working on. And he's like, why did I break? I had no idea what was going on, right? So you want to control that, unlike Git, or unlike Dropbox, you want to control when those files get updated. And that's what this is doing. So we just did a push, right? Makes sense. We pushed it up into the cloud. Well, we can also pull the latest version down. So, keyboard in the wrong place. If you do git pull origin master, what it's doing is going to the cloud and saying, give me the latest version of this master branch that's on my origin, that's on the origin remote repository. And then it should tell you what changed as well when you do that. Like here it'll tell you, oh, we updated. Here's a new file that didn't exist before. We fast forwarded and added a new file to your local files that wasn't there before. And if we look, we'll see, well, maybe it's not there. I don't know. Maybe it's inside the octo family. If this works, it may not. Like I said, there's very limited capability here, right? This isn't attempting to be a full environment, so I don't know how far I can push it in terms of what it'll do. But it does tell us it's created this new file. So now it says, uh-oh, looks like there have been some additions and changes to the Octocat family. Let's take a look at what is different from our last commit by using the git diff command. All right, git diff head. And so what head does is, you know, we've got this series here, these dots, dot, dot, dot. Head is always pointing to whichever one you're on currently. So it's saying this is the point in time or the change that you're looking at. And so if we look at this git diff head, it'll tell us, oh, it looks like one file changed, octocat.txt, and it looks like it changed by, this is not very easy to read at first. This is something you'll just get used to over time, hopefully, and there's a lot of tools to make this easier to read. So, you know, especially outside of Cloud9, inside of Cloud9, it's a little bit harder to see all these changes, but outside of it, there's a lot of Git tools to make a lot of this stuff a little easier to read. But this is basically saying there was a change, and a line got removed and a line got added. And then it says another great use for diff is looking at changes within files that have already been staged. Remember, we've got that sort of three-step process. We've got your working directory, and then you can stage those changes, and then you can commit them. So let's use git add to stage octo family octodog.txt, which I just added to the family for you. So git, yeah, in the wrong place apparently. Git add octo family octodog.txt. And now we can git diff -- staged. And these aren't, this is showing you a lot of the capability of Git. You're not going to memorize all of this. You're going to live off of Git cheat sheets. You're going to live off a very small workflow at first and sort of let it grow over time. So basically it's just saying, all right, we made some changes to this too. We added a line to it that looks like it says woof or something. Now we have the step says, so now that Octodog is part of the family, Octocat is all depressed. Since we love Octocat more than Octodog, I don't know why, because the internet likes cats more than dogs. The internet's wrong. Just to be clear, dogs are definitely better than cats. But the internet can be wrong sometimes. We'll turn his frown around by removing Octodog. So you can unstage files by using the git reset command. So basically, if let's do a git status real fast first. Git status. And what we see is we've got this new file, octodog, that says it's staged, it's ready to be committed. So it's not in Git yet. It's sitting in that staging area. And there's been some changes to Octocat that we didn't like, but we don't want to add this octodog file. We decided, never mind. We didn't actually want this. We can reset that. And sort of get rid of it. But the interesting thing is if we do a git status now, what you'll see is it tells us we've got a modified octocat.txt, but this file, this octodog, still exists. And that's because when you're making these git commands, for the most part, most of them operate on the staging area or the git repository and not on the file themselves. So all we did was unstage it, which took it out of this sort of Git staging area. It didn't delete that file or get rid of it on our file system. And so that's sort of annoying. We've got this file sitting around that we don't want. I mean, we could delete it now because it's not being staged or tracked by Git, and it would be fine. But they say, oh, let's just clean this up instead by going back to before that happened. And this goes into this sort of history bit that I was talking about, being able to move backwards and forwards on it. So what we're going to do then is just git, of course it's in the wrong place, git checkout. Come on. Oh, I didn't even notice it was showing me my repository down here. Look at that. Should have scrolled down. Git checkout -- octocat.txt. And basically what that did was reverted the changes so that the cat, any changes that had been made to Octocat since the last time we committed, all got stripped out and it just went back to the last committed version of that specific file. So any questions about this so far? Yes? If you do a checkout, you can't go back to that version of the file unless you've committed it. So you can check out old versions of files if you want to. You can tell it like, oh, check out a version from, it gets a little complex to do some of that stuff. Not too bad, but it's not something that you're just going to, do off the top of your head most of the time. But unless you've committed those changes into Git, if you check out to go back to an old version of the file, then they're lost. Anything that makes it into the Git repository that's been committed all the way through, Git's going to hold on to that history unless you do some pretty brute force things against it to say, get rid of it all, or you delete the folder, right? I mean, it is just a folder on your system. But other than that, anything that you make, any changes that you make to files or stuff like that, until you commit them, if you get rid of them, you won't have that history, which is why a best practice when working with Git is to commit frequently whenever you feel like you've got something in a working state. Like even if you added one extra line and it's working, you feel good and you're like, all right, I'm logging that information now. All right, I can commit that, and that way I won't lose that history, that state. You have a tendency, I think we all have a tendency, right? We're like, oh, I want to get everything added in before I do this git commit. And so as you start working on larger projects, you'll be like, oh, I've got these 20 different files that I've changed, and I've made changes to all of them, and you haven't made a git commit of any of those changes. Well, now you've got a lot of complex problems because you probably made changes that you did want to know about. Or sometimes you may be like, oh, I want to go back to that version that I was working on, but I didn't save it specifically, and I made more changes on top of it, and now I can't get back to it. And so if you've committed as you're working bit by bit by bit, then you can always go back to any previous version and be like, oh man, this was horrible. Get rid of all these changes I just made. They didn't do what I wanted at all. And so another tool to help you out when you're doing that, you don't just have to have one timeline of all your file changes. You can make a branch, and a branch is very much like sort of what it sounds like on a tree or something, where what you do is you say, oh, let me create another timeline here with some changes that's separate from this one. I've branched off somewhere else. And I'm making some other changes here. Maybe this is a feature branch. You're working on something specific, or you're trying to solve a bug, and so you go off and create this separate branch. And maybe the way this might be more relatable, I don't know, maybe when it's super sci-fi geek, but think about your time traveling movies, like Back to the Future. They're like, oh no, I created a separate timeline. And now I've got a problem because there's different timelines that exist, and how do I deal with all of that? Well, Git encourages you to create these, but you still have the issue of needing to bring them back together at some point, right? The same type of problem you would have with timelines like that. So sort of the next step here that it has in our walkthrough is creating a branch. So we'll create one, git branch, clean up. And what that did was create this branch, but it didn't yet, this is where it gets a little tricky. Most of the time you probably won't do this as a two-step operation because it's just not something you end up needing to do that way. You'll do it as one-step operation. So what that did was create a branch, but it didn't change our files to point to that branch. At this point in time, we're still pointing here, right? It's saying, oh, we're still on this branch. But we've created another branch. So in order to move to that other branch, you need to do a git checkout. And that's how you switch between your branches. So we'll check out this cleanup branch. And now we're in another branch, and now we can make changes in that branch that won't directly affect our master branch that we were working off of. We can finally remove all those pesky octocats by using the git rm command. We're going to want to use a wildcard. This may be similar if people remember using rm inside of, the console before. This is just wrapped inside of git so that it also removes them, puts it in the staging area that way for you all in one step. We can do git rm star.txt. And now if we did a git status, what you'll see is there's a whole bunch of files that it can already see are deleted and sitting in the staging area. And the reason that they're already in the staging area as deleted is because we use the git rm instead of the rm command from the console itself. If we had used the one built just into the command or the console, then we would have had to stage them like git add or whatever manually. So let's go ahead and commit that. Remove all the cats. That's right. The dogs are happy now. Everything's good. Great. You're almost finished with the cat or the bug fix. You just need to switch back to the master branch so you can copy or merge your changes from the cleanup branch back into the master branch. So we'll do that. So this is the idea of switching between branches. So if this is our cleanup branch, now we switched back to the master branch instead. And now we can go ahead and merge these changes. And this is where some of the power of working off these branches comes into play. So we'll do a git merge cleanup. So basically what happened here, going back to our timeline, and this timeline doesn't perfectly match the commits that we've made, because typically you think of each one of these dots as a commit, is we have a master branch, and then we branched off into this like cleanup branch, and we made some changes. And now we want to bring that back to our master branch so that anyone who checks out that master branch will get those changes. And you can think of it like this. We're saying, all right, come back to the master branch, and this one comes all the way over here, and it is right there, and it says, all right, merge these changes back into this branch, right? Now in this case, this is sort of nice and clean and easy because there's no dots here, right? So we didn't make any changes on this master branch between. But it is possible for somebody between these to have made other changes here. And that's where you get into a more complex merge where, yeah, if you didn't touch the same files, it may work. If you touch the same files, you may have to do some extra work to merge these two branches together. Because you created separate timelines. Up until this time, we branched off into a separate branch, but it's not an action. We didn't continue this timeline. Just sort of sat there, and then we jumped back to it. We're like, all right, everything's good. once you've made changes in both timelines, now you have to deal with the conflicts between your timelines and how do they work. Right? Marty McFly may fade away or something, I don't know. So now that we've merged that branch in, yes?
Okay, so you branch out. That's saying the dots, they're not on that, they won't show up.
They don't at first. So what'll happen, depending on the way that you bring your branches back together, right? Let's look at it right now. Let's do a git log and see what happens. So if we look at it, what we can see is we have removed all of the cats in our log along with our 2 previous commits, right? And that's because when we merged our branch back in, our cleanup branch, one way you can think about this, if you want to, is Git doesn't keep track of like these branches this way. Really, all Git keeps track of is the series of commits that have been made at any point in time on any branch. And so, you know, we draw it out this way, and it's a pretty common way for it to be drawn so that it's easier for us to visualize and think about. But you can imagine that once you've merged back in a sense, Git itself doesn't know that there's a difference, that this was up here. It sort of shifts all of these down. Just says, oh, here's my one timeline now of every change that I've made. So while we worked with a different branch, it was sitting up there doing some other stuff. Once you've merged it in and it's all successful, all Git knows is, oh, I've made these 3 commits. It doesn't know that one of them at that one point was off in another branch and came in. It just sees it as a series of 3 commits now that have been made. So it collapses that complexity at that point in time. So it doesn't have to continue to think about all the different branches that you've worked off of. But that branch is still sort of sitting out there, and you could make other changes on it. Like you could go back to that branch and change other things. But usually when you finish something, like, oh, I finished the cleanup, I merged that back in, you want to clean up your branch. You want to get rid of it so that it doesn't stay around and you don't use it anymore. So that's what this git branch -d is doing. It's deleting it. And you just tell it, delete the cleanup branch. And it goes ahead and cleans that up and deletes it so that now there's a lot more commands to this. So if we did like git branch, you can see all of our branches. And right now, all we have is master. Whereas before we would have had master and cleanup. I know it's really hard to see, I'm sorry. So we've made all the changes we want. And now those are all just sitting locally on our system in our own Git repository. We've committed everything, but they're not yet in the cloud because we didn't push them up there. And so that's sort of this last step. Oops. Scroll back up, scroll up, you where we want to go, is Git push the last set of changes that we want. And now those changes are also up in the cloud in that repository so that if another developer wants to get those changes, they can pull them down from our shared cloud repository and work with them. And that's really how you end up collaborating, is each developer on their own system, right? This is one system, one person's computer. Somebody else is going to have a different computer over here, and another one, and another one, and they're all connected to the same cloud and pushing to the same location, pulling from the same location. And that's how you sort of share code between people. Okay, I finished everything I wanted to do, I push it up. And now somebody else can pull down the latest version of the master branch and get my changes and work with those. And maybe they're working on a different branch. They're working on the restore the cats branch. And so they do that and they push that branch up. And somebody else wants to collaborate and work with them on restoring the cats. So they can pull that branch down and work off of it as well. And that's part of the value of Git, is this very collaborative, distributed model where you can work with stuff locally, make changes, keep a local history, and then push
push it up into this environment in cloud where you need to share that information with somebody else.
Just as a comment, we used to have really complex branches for production website, for example. You'd have one branch that was the live site, for example, that was like nobody touches. And then you have another one for quality assurance people. You know, they wanted to test things, so they wanted their own specific branch. And then you had a testing for a future, you know, this is our release going out next week, and that was yet another branch. And it just goes on and on, but it's so flexible and it's really helpful.
Yeah, I mean, it makes a huge, right, it makes a huge difference working in a team environment with something like this. And I mean, you get incredible use out of it just on your own, like I was talking about. You don't have to maintain separate files and history of these files. So just being able to keep a history of every change that you've made or groups of changes is already great on its own. But once you get into the collaborative model and you're sharing your content with other people, I mean, it can be unusable to do like high-level software development without something like that. I know there have been some companies that have done it in the past, and you know, had massive folders and other ridiculous stuff. Like, so, are there any questions right now? I mean, this is a lot of concepts to sort of start working with. I mean, especially for people who have never worked with a source control tool before. It's not something that you're going to understand immediately all the way through, like what's going on, how it's working. Some people say Git is like really confusing. I think that the command line for it can be very confusing. There's a lot of specialized commands and other things, but the very basic level I don't think is necessarily that bad. And then, as I said before, you're not going to remember all the commands you need to run. There'll be a few that you'll consistently use, but for a lot of other stuff, you're going to have something like a Git cheat sheet to help you out, and there's tons of them out there that help you through. And then there is I'm gonna Google this and probably regret it. I think there's sites like Challenge sometimes when you're working with it and you're like, oh crap, I did something wrong and I don't know what I did and I don't know how to fix it. And so there's some really useful sites out there that help. They're like, oh no, I made this mistake. Here's how to help solve that problem. Oh no, I made this mistake and I don't know how to fix that problem. So there's a lot of really, really useful sites that help walk you through like, oh crap, I don't understand how to solve this. Well, here's just a little, set of steps to do to help solve that set of issues. So the fact that those sites exist should already tell you when you struggle with Git and get into some weird state with it, this is not a problem that's unique to you. I don't know of any developers who really just know all of the internals of how to do all these commands with Git. They keep a cheat sheet handy, they keep a reference handy. They know the basic concepts of how stuff should work, or the workflow that they use day in and day out, which might be a little different team to team. But knowing all the commands and all the complexity of it, unless you are a maintainer of a large open source project, which, by the way, the reason Git came into existence was Linux, which is a open source operating system. The creator of Linux felt like they needed a better source control management tool to manage all their files. What they already had just wasn't working for them. So they basically created Git to help them manage the source code for Linux, which is, I don't even know, 400,000 files or something like that with millions of lines of code in them. So it's very complex to manage all of those changes. And that's what they were trying to help accomplish with Git, which, the fact that it's a tool that can manage that much and also scales down to let you manage just a few files locally is pretty impressive, and also helps explain why it can be such a convoluted tool and has so many different options and stuff.
All right, any other questions on Git right now?
One other thing, I think this probably, you guys may all already understand this, but just to point out the obvious, to Git, just to be clear, it's not limited to working with JavaScript or React or even web development as a whole. Like, so the good and the bad of so many, this is true of a lot of the things we covered in the last class, really everything from the last class, and a lot of what you'll see in this class is the good and the bad of it is unfortunately it's like all so fundamental that you'll need it all over the place. Like Git being at least understanding the basics of Git is something that you would need for I don't know for all software jobs. I don't know if that's an overstatement or not, but just about.
It's pretty close now. Like 10 years ago, there were a lot of different source control tools that people were still using. And there are several, I mean, there's still a lot out there, but Git has become way more dominant as the common tool versus all the other ones at this point in time.
That's a good point. So even if it weren't Git, like understanding that this type of concept may be necessary. So I kind of think of it, when I am exposed to these things for the first time, I don't know how many of you have ever tried to learn a foreign language. I think, well, a lot of you may have learned a language, but you were so young you don't even remember the process. For me,